hell's going on here? Yeah. There's 2 points and then find the maximum. After finding the maximum, we want to find a minimum, and well, we didn't. Sorry, this is a jump point. We didn't find it yet. Okay, now we found it. Apparently, the 4th degree polynomial looks like this. So we go that way, and yeah, that should be jumping here. I guess, okay. Here's 2 points. Immediately have a maximum. So we need to get a 3rd point, extra point. That is this one. And then it fits 4th degree polynomial. And we go to the right, and next we want to go to a minimum, and it just fits the. Yeah, it just fitted the curve exactly because it's fitting a 4th degree on top of a 3rd degree. So the next jump point is like that. Next, we go here. Found already extreme. There's only 2 samples, so it's going to ask for another one. What would it ask? Why does there only 2 samples anyway? We have -3 and -2. Okay, so the -5 is not used because it's too far away, I guess. Yeah, okay, the scale is 1.666 and this thing is 2, so that's too far away. Hello, Rudra. I think it's going to add the scale to the 1.666 in this direction. Just -3 minus 1.666 is minus 4.666. Yep. Which is there. I have mixed feelings about this because it's an extra probe here of the function, and really, why would you do that when we have already 0? Feels like we just should use 0 because 0 is a symbol that was used to fit the last cubic. change that. Here I'm adding the other sample of the used cubic, but I'm only doing that if the number of usable sample equals 1, in the case that state is still unequal extra sample. But now I'm having a second thought about that. Maybe I should not. Maybe I should just, you know, always use it. I don't know. Just try this. Less than 3. Yeah, actually, no, this is not true anymore. I don't know if that is the case. I think that I should just always add them. So cubic used and cubic used next sample. They should always be added, independent of the distance. Actually not independent of the distance. I wouldn't want to add them if this is the case. This distance. Only when it is too large. Now wait a minute, it's the opposite. No, what the fuck? It still added 3. Man, what the... How is that possible? First one's here, the second one's there. Now we jump here. And yeah, it's gonna ask minus 4.666. Why? Not enough samples. You have to intercept this at with the value minus 3. That is minus 3. Second time, I guess. Continue work again. Still minus 3. How often are you going to call this? This is another test. Nope, this is the first cubic test. I don't get it. I really don't get it. Up. 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 We are here. It is not edited. Yeah, it is a different test. Let's get rid of all tests before the one that I want to debug. Step into. Yeah. Okay, now at least we get a window. There we are. So let's see what happens. Next. Does anyone have trouble reading this because I'm at a small screen? That was a small font. Okay, next. Scale value. So scale value is 1.6666. And state is find extreme, I guess. Yep. And W is -3. So the last point 2 is the maximum, and that is at -3. And the larger sample, there isn't a larger sample at -2. And then we set right to point to that sample. So right now points to sample 1. And left, I guess, point to sample 0. That logic here escapes me, but okay, whatever. So right is sample 1. Yep. And left is actually sample 2. Okay. Okay, whatever. If right is not pointing past the end of the chain, it doesn't. And the absolute value from right to -3, the extreme, is not negligible. Sorry, is negligible. Then we use right for the last extreme, but that's not the case because right that disappeared. Well, right is like at a distance of 1, so that's definitely not negligible. And then left is actually negligible because left is just the exact same thing as W. Now note that for W, I have W value, but you do not have a sample. However, because left W value, left is a sample, And because the left W value is equal to W, this is definitely going to be less than a negligible offset, and therefore we will use left as the local extreme sample. So last extreme, it is the current local extreme, is now sample number 2. Okay, my drawing is back. This one. Then that of course that is the local extreme. So we mark it as a local extreme, as a maximum even. That is a maximum. Not a minimum. So since it's not a minimum, it's a maximum. I do some sanity checks here. Nope. Now I'm going to define left edge and right edge, both of which start at the last extreme. With extreme W value, which is minus 3, of course. And then we're going to find all samples that are within the scale distance from this minus 3. And now this distance is 1 and this distance is 2, and the scale is 1.666. And even we multiply that by with 1.1 even, so then you get I don't know, something larger. 1.66 times 1.1 is 1.83. So this is less than 1.83 and this is larger than 1.83. Therefore, this sample is ignored. At least that was the case. But now I wanted to include it because I thought maybe that's what's going wrong. 0 is just not. 0 is not a sample that is part of the used cubic. I guess we used the cubic between 1 and 2. Instead of between 0 and 2. Boomer. Okay, let's see. We can make this a little bit shorter. I can just print the W value. So minus 5. So yep, this is 0 now. As you can see, the ID is labeled 0. And I thought that would be accepted because I thought it was part of the used cubic, but apparently I guess it's not the case. We used. Nope, it's minus 3. Okay. Yeah. Well. Yeah. Then these the one and two are are the samples that are used to fit the current cubic, and zero is too far away. Still think it's stupid to do an extra probe here. Let me think about this. Okay, yeah, I think that it's not really the fact that a sample is used to fit the cubic, it's about the scale. Zero was used to determine the scale, as was one. So I did a weighted average between the distances, as in we have something like this distance squared plus this distance squared divided by something. No idea how I would get 4/3 from that, but okay. Hmm. Can we make that visible? Like, if I print a used cubic, does that thing not have a scale somewhere? Yeah, scale. See there it is. We have a left edge at -5 and the right edge is -2. I could use that. I could use these two as the limit. Okay, try to get to that value. I don't see an accessor for it. Oh yeah, left edge W. Oh. So I have the scale. You can call this. Gradient. Gradient. Algorithm. And then the code that I just changed. That was this. Yeah, so we don't care about this. And this I can replace with left edge W is less than 1.1 times left dist or something. Dist scale, fake scale. New invention, left scale. Skip if the distance is too far. Plop, too far. The other way around then. And then the other one was here. Yeah. Right edge equals that or that. So this is the distance is less than. We'll be changing that into less than the right scale. And then you have to define the right scale and the left scale. So we need to get the scale here, something scale, and then call left edge on that. That returns a double, yep. Well, I have a scale value, that was should tell me where I got the scale from. It's just the scale of the used cubic, of course. Let's search for it anyway. Yeah, this is the scale. Undo, redo. That returns a scale const reference. Let's put it here. Okay, let's see what happens. Jump to 2 and we crash. Number of usable samples equals 2 filled. What? I thought I made my criteria more, what is it? What is the word? Wider, so I would get even more samples. And now we get less samples. What the hell? 1. It's because I commented this one out. But that's because, yeah, it should add 0 now. So didn't, clearly. Number of samples is 1 and we only got the -3 one. Ah, really? Yeah. So it did not even get the 1 now. It should have gotten everything, but we only get that one. So definitely time to debug this again. Snore. Brick. It's just the same thing as before. So this is still -3, of course. Okay, I think I must have done something stupid. So last scale should be -5. Yeah. I've got to multiply it with 1.1. I'm going to do that. Might as well do that here, huh? Instead of in the loop. So only is if it. Wait a minute, it skips it. Yeah, that's not correct. Must be less than now. No longer comparing distances, but absolute values. So too far to the left, that means less than. And this is inclusive. But that's the right one, so that should still be less than or equal. Oh, wait a minute, the 1.1 is now bullshit, of course. Damn it. Because it's no longer distance, it's an absolute value. So multiplying that by 1.1 would just shift everything. Let's see how these things are assigned. If they are assigned directly from the samples, which makes sense, then maybe I can just compare the Boolean values that's being set by something passed to set. Find that back. Bit not found set. Really? Yeah, these are samples. So it just copies the W value from the sample. And it should be possible to compare that with the same value. We think. Definitely samples. Okay, I completely forgot which file I should edit. Oh yeah, of course, just handle local extreme. So this is the W value of a given sample. Those samples are ordered by that W value. So less than means it's not equal, it's on something on the left side. Equal means we want to include it. It's a bit scary, but it should work. Yeah, so now it worked. because we have immediately a fit without asking for sample number 3 here. So just use 0. Of course, you can see that here as well. Fitting a 4th degree polynomial using samples as -2, -5, and -3. And we immediately had 3, including -5. Note that it's kind of random which direction it goes into, because it does fit a 4th degree polynomial on top of an, in fact, 3rd degree polynomial. So the approximation is something that is very close to a 3rd degree polynomial, like the 3rd degree polynomial. But yeah, it requires a lot of calculations with doubles to find that polynomial. So we, due to round off, floating point round off, we do get 4th degree power of 4w as well, with a very small coefficient. But it's going to be there. However, we don't know if it's going to be positive or negative. It's around 0. And the stupid thing is that that sign determines which way we go. Yeah. But yeah, it's not really that bad. I'll explain if I have viewers. Let me check. 2 viewers. That's a standard default 2 viewers who might not even really be watching. I don't know. The point is that the 4th degree is now the 3rd degree, so the derivative is more or less a parabola, and then the derivative of that is more or less a straight line. While if it would have been a 4th degree, then this one would have been a polynomial. So this blue line goes through 0 when this one is horizontal, which is here. This is the 0 here, so keep. But it's a polynomial. It's not really a straight line. It's this thing. So this is the straight line, and then we have a very, very small coefficient for the 2nd degree of W, which then, depending on the sign, causes another extreme, another point where it goes through 0, another root at plus or minus infinity, more or less. In this case, we have at 14. Well, that's the actual thing here at 14. A root of the blue thing, and then we have one at plus or minus infinity. In this case, at plus, very, very big. And yeah, if it is a plus, then it's going to reject that, because if you go extremely far to the right, then the actual function is going extremely far up. So it's very, very, very positive. We don't want that. So we pick this one. But if that random number has a different sign, then this blue straight line is curved the other way. And we have another, now it's this blue line is now curved like this. So it cuts through 0 again, very, very far to the right. And otherwise it's curved like this. So it cuts through 0 again, very, very far on the left. And then it says, oh, but that's nice. We are looking for a minimum. And that's like really deep, because this goes to minus infinity, of course, in that direction. So then it says, okay, let's go to the left, because we are looking for a minimum. And then it doesn't even go to the left. No, it goes to like minus 10 to the power minus, 10 to the power plus 14. Negative there. Wow. Completely ridiculous, of course. The only measuring points that we have is these three. And normally in machine learning, you don't have an infinite deep thing. You just have normal minima. So that there is no reason to assume that this goes down, down, down forever, and let alone that it goes down like billions and billions to the left. It's just nonsense. But yeah, I don't know. That's what it's doing now. Anyway, in this case it says that it wants to go to 14 because the other one has a very large positive value. So press the space bar here. Yep, so we go to that one. And this one too. And this one is just curved the other way. So it looks like a straight line. It's curved the other way. Now it wants to go to the left. Which means now it jumps to this number here. That's ridiculous. Yeah, HVZ. I know. I just want this to be finished, damn it. It takes way longer than I wanted. Than I want. But stopping is not an option. Just have to finish it. Okay, now it doesn't go for the maximum, it goes for the minimum. And then I think that now we have a different situation, because if now this is still a straight line, right? Because this is a third degree instead of a fourth degree thing. Almost a straight line anyway. But still randomly we want to go left or right. However, no, anyway, it wants to go left now, so we just jump there. Still go left, we jump there again. And now we start in the minimum again. Okay, we get that one again here. Then we go to that side again, so nothing, and then we go to here again, point. Now we start here, and it wants to go that way, so we go to this. And okay, what is that? Oh boy, interesting. Infinite loop. But this is my last project. I'll continue with this till I die, I guess. Or until I can't code anymore. Which is getting close, I feel. Due to old age. But this sub-project, finding the minimum of a function, that is going to be finished. And then just continue with the project. I mean, it's called machine learning, so there is absolutely no end to it. Why do we have a loop here? It finds a local extreme at -4. Oh, that's not true. The extreme is at -3. -3 is extreme, so why would it say that -4 is an extreme? Oh, the CX sample thing. Ah, okay. So we are here and we need an extra point. And the point is 2 at -4. And then we call handle local extreme again, and that should just pick up where it left off. And now we have 3 samples. At least that is what should happen, but still 2. -3 and -2. For some reason the -4 that we pass here is not picked up. Okay, I guess this is that there's a round-off problem anyway. I thought that the value of pass here is oh yeah, okay, wait a minute. Yeah. Go. The scale is determined without using tool. Right. Yeah, that kind of makes sense. Oh, right. Oh, right. Okay, yeah. Oh my God. Yeah, it could be that this is only happening for the extra sample. Theoretically, I should update the scale, I guess, using the new sample. But I'm not, because it's an extra sample and I'm lazy. I could just say that whatever we pass has to be added or included as well. Yeah. Okay, so we call handle local extreme. In the case of extra sample here. And now note that if we do this, then we did not change W yet. So we go up, so we'll go to the beginning of the switch. So we can come from here. It is an extra sample, so we must come from here, not from the bottom of the loop. So we have a new node that was inserted in the chain using current, where current is constructed from W. So it must be the case that the W value that we pass to handle local extreme equals the W value of the sample that was last added to chain using insert. What am I doing? Lots of inserts. It's just this one, which sets last to point to it. So chain last points to a sample that we must add if the state equals extra sample. Yeah, getting that in here is difficult. I think I'll just compare it again. Just compare the iterator. So skip is still too far to the left and is not the extra sample that we just requested. Yeah, I think this works, hopefully. I'm starting to wonder now, we might get too many samples on one side. Nah. Can hardly believe that. Okay, so we have to define extra sample now. Oh. Hmm. Yeah, I can even see that here. So label 1 is here as well. So 0 and 1 are at exactly the same spot. How did that happen? Especially because before the last change, that wasn't the case. That didn't happen. We're adding -2. We're adding sample 0. I mean, add -2. It wants to jump there, we ignore that. The test suit overrides it. So now we go to -2 again. Okay, that's weird. Oh, let's find larger, sorry. Nevertheless, then we enter it again with -2. So yeah, what the hell, dude? How on earth can this happen now and it did not happen before? Oh, W wasn't changed, I guess. No. Huh? What the hell? Unbelievable. Ah, yeah, okay, I got it. Oh boy, yeah. So I wanted to debug I0 is 0 and I1 is 3. There where I just hardcoded the 3 here. But really it must be larger than I0. So now we continue running for some reason just until I0 equals 3 and then they are just the same thing. So let me get that assert. Yep. Just put that back how it should be. I think I commented out something else. What? But I used the C comment. No. No. So I'm not really getting that. No. That's the 3 thing. Anyway, another one. Asking for a minus infinity. Yeah, this case we had an exact linear thing. Apparently I'm not taking into account that it can look like a line, or even is a line in this case. So I probably should say that if it looks like a line, like the previous cases, we had something like 10 to the power minus 14 as coefficient. That's almost 0 as well. So might as well treat it as a line in that case, which means that we have only one root instead of 2. Okay, so I'm kind of confused. I copied this code from the previous version and I never ran into this. I suppose it's very, very, very unlikely, but yeah. Especially since the current cubic is generated such that everything is integers, even though these are doubles. But they are generated as integers, and then even the derivative has integers. That's how it is generated. And then still we got a round of errors. But at least now there is some hope that if you do calculations with pure integer doubles, that you get something out of it that actually has a 0 as a coefficient here. Okay, let's see. You're telling me that get zeros isn't working in that case. Should just return 1 0. Get zeros is broken. Just doesn't take into account that this can fail, apparently, at all. This is 0. If only we had an AI that could code, could paste it to it and then say, please make this numerically stable. But I'm not even going to try it. So what is a good way to detect that my parabola is basically a straight line? And you can't know that if you ask me. Can't know that if you only have the parabola. It's just a parabola. You could do a super wild guess that if the zero of the straight line is like billions times as smaller as the other zero, then that you can ignore it. But suppose that one of the zeros is for whatever reason 0, then the other zero would be ignored. And we don't want that. It's not easy. The only way to do this if I would pass a scale here. My current scale. And then ignore anything that is larger than many times the scale. Maybe this is a good thing. So if this is 0, then it's definitely not possible because it would have to divide by 0. Now the question is, how close to 0 is almost 0? Well, I would argue, if this is not 0 but very small, then maybe d is going to be basically equal to the square of coefficient 1. And then we can say, okay, it's neglectable if the size of this thing is much smaller than the size of that thing. Because if that is the case, so that, say, a good approximation is to say d equals just this, and that is neglectable. Then the square root of d equals the absolute value of the coefficient of 1. And then we divide that by the absolute value of 2 times the coefficient of 2, which gives us then the absolute value of coefficient 1 divided by that, aka the absolute value of this, which means that one of these is going to be 0. No. Sorry, that's nonsense. Well, yeah, actually, yes. Except that it's not 0 then, because this tiny little amount that it makes it different from the square is then becoming significant again. So in the end you end up with something that is proportional with the coefficient 0. So then one of them becomes this, of course. I don't know, let's just type some stuff. Coefficient 0 is A, coefficient 2 is C, and coefficient 1 is the B here. I'll do it for CA, so it is the same order as here. Yeah, 2 times 2 is 4 and the B cancels, so this is just the same thing. And then this is the square of 2ca divided by b, which is much smaller than 1 because of this. Therefore, you can add that and still have something that's more or less the same. And then the whole thing is a square, namely b minus this, all squared. So the square root of that is then the absolute value of b minus this. Is that correct? Yeah. You get rid of that absolute value thing. delta is absolute value of b minus 2ca divided by b. Divided by 2c. Yeah, that's just this. I guess the borderline is that if this becomes numerically unstable, then we should consider it as being a straight line. And that means that this is it should be 0, but there's a danger that due to floating point round-off errors it's not. And that means that this value is just much larger than that value. Which, if you multiply that by 2bc, now you get b squared is much larger than 2ac. Your type it like this. I think 1,000,000 times is definitely much larger. Possibly could even use something small. But if I use something smaller, I can't treat it like a straight line anymore. But I still want to have a numerically stable expression. So, kind of like assuming that this is not true, but avoiding round-off errors because of the subtraction of two very large numbers. Yeah, even then 1,000,000 is pretty good, actually. I don't think I need a double special case for that. So let's do if Might as well use D. Much larger than 2AC is also much larger than 4AC. Which means that D becomes very close to the coefficients. The square of the coefficients of 1. So yeah, by doing this, I effectively set coefficients to 0, which could be the case, meaning that this is 0, therefore this is definitely larger than that. Coefficient 1 is never 0, is it? Because I'm even dividing it here. Well, actually I have to return 0 in that case. So is normal normal? is normal. Although in this case it makes not that much sense to test it because D is larger than that one. That means that D is not 0. Which means that this is not 0. Which means that we can divide by it, I think. Yeah. Going to do 1. Just, I don't think this can happen. And if it does, then it's not a normal thing, and then we'll crash anyway. So I'll know. So what about the numerically stable thingy? And basically, really, we want to have this formula, but written in this way to I guess it's not important. It's probably not important. Just get a tiny error in the 0. Yeah. Well, that worked. What about this? Annoyingly, I saw one thing that I skipped over. I'm gonna do this slower. So we go there, and then there. Yeah, what the fuck? Hmm. With one autolog stream. It's not right. Right. What the fuck? Still. Oh. It's doing it still. Oh. Unbelievable. Fucking fly. That's the fly. Fly got scared. So yeah, now we found a case where this is true, but I do not want to ignore the other case. It's too hot. Gonna play chess. Yeah. Play one more. Haha. Okay. That's a good bit. Good night, people. I'll be back with the coding tomorrow.